Welcome to lesson number 3 of 13. This lesson is going to go fast, so you'll be able to stop it, play it back, rewind it, whatever you need to do in order to get what you want out of it. It's also kind of an unnecessary lesson if you already know what you're doing, but I will show you how I prepare for making maps. Maybe you can glean something from this. So this is all about getting the data you need for maps and storing it in a logical format before you ever get your map started. So gathering data is the phase we are on. The first thing you kind of need to do is set up a logical file structure. And then you need to download all of your files and then place those files into your logical file structure. First thing I'll show you is my file structure. I recommend that you start with 2 folders. One folder that has all the raw data that you're going to use, and it has a series of subfolders inside of it. Maybe a folder for contours, maybe a folder for your digital elevation model, some just random GIS data that you get from different places, imagery, Cartapoo-Lawton data, LAS files, miscellaneous, OpenStreetMapper, all the raw data that you use. So place all of that into a directory structure. And then when you start manipulating your data, which we will do later on, you're going to want to take some of that raw data that you have in all these folders, and you're going to kind of want to replicate that folder structure. But what you're going to do with each of those pieces of data is you're going to save them into the format that you're going to use your main map in, and you're going to clip it down so that you're only using what you need. Once you have all your data that has been trimmed down to the right size and in the right coordinate reference system, you can delete this folder, or you could save it for future use. It's up to you. But these tend to be very big in size, so they will eat up your computer real fast. So this is sort of the structure that I use. I just mirror both directories. I have a clipped area and a raw area. So with that in mind, I'd like to talk about where I get the data and what I get. First is you should do is just do a search. Just do a Google search for GIS data. If you're working in a city, say Hong Kong, or in my case, Kirkland, which is a suburb of Seattle, they have their own internal GIS department, and paid professionals are keeping track of lots of data for you, so you don't have to do it. This is the stuff you want for free. This is why we're doing this. Go see if they have that data. If I go look on the Kirkland, Washington government website, I see they do have a GIS data download portal. I select it, and I can see what they have. They have some random stuff here that are just basically copyright stuff and other nonsense, if you will. But there's also some things in these directories, such as environmental, where they take all of their environmental data and they can give it to you in either a shapefile format, a KMZ, which is a Google format, a GeoJSON, or a geographical database. Just save it. Save your file as a shapefile for our purposes. It should zip it up for you. And just select the full downloaded zip for this, which will consist of all of these different zip files. And then we'll go back and do the same thing for each of these. The general download that has docks and lakes and neighborhoods and parks and schools. The non-motorized transportation, which if you open that up, it has crosswalks and school routes, and it also has a trail inventory file. And so we're going to do that for all of these. And when it's all said and done, we would have a pile of files that are all zipped up, and then we could put them into our raw data directory. So my raw data directory would have this file that says GIS data. And inside of that, I'd have each of these set of shape files. And so it's a lot of information there that I can use. And as you can see, if I open up Qgis and I take those files, I can take them and just drag and drop the shape file onto there. And now you see these are all the docks around Kirkland. So we can do that quite easily. All right, so That's one spot you can get GIS data, is the local city. And I've got all of that data that I've just showed you there. And let me just throw a few more things onto our map real fast so that you can kind of see what we have going here. I want to go with the environmental as well and see if there's any water. So there's streams, which we're going to want, and let's get the wetlands in there. So those are all wetlands. Those are going to be important. The streams will probably obviously be important. And we can also go into the property and see if there's some building footprints, which there is. Those are all the building footprints. I can go into the transportation, and the impervious surfaces is a very good file which shows you all the concrete. And so right off the bat we have a map that's starting to look pretty good. It's just a matter of styling at this point. And Qgis, you don't have to worry about styling, but when you get good at it, you can set up your own quick little styling setups that you want, such as the standard colors for orienteering maps. You can just select those and quickly have anything you want. So we've got our data from the city. Let's just go and see what other kind of data we can get. The very important thing you need for orienteering maps is obviously contour data, the terrain description data. And the best way to get that is through LiDAR. Now there's different places to get LiDAR across the world, of course. I'm going to show you where we get ours in Washington. There's two main places. There's something called the Puget Sound LiDAR Consortium. And if you select their homepage, it'll look like this. The website is pugetsoundlidar.ess.washington.edu/index.html. And you can do a Google search for that as well. And when you get there, there'll be a button that says data, and then they go ahead and get your data button. And you select that, and it says there's some places you can get data. And they have links to other places, but they also have their data, which is PSLC data. So in our case, we'll select that, and then we'll look at a list of projects that they have. And this map that they show on the screen shows all the different projects they've done. But at the bottom here, we have a Western King County, which was done in 2016, and that's what we're looking to do. And we'll select that, and this shows you what was done in that project. They delivered the LiDAR data in 3 different delivery blocks. Delivery 1 is the area we're talking about, which is around Lake Washington. And you see, if I want to see that data, I would select the Delivery 1 button. And it would take me to this page, and this is a very important page, and there's going to be a metaphorical same page or same set of information that you get from whatever place you get your LiDAR from. In our case, it has a description of the product, and and it shows you up here what the projection is and the horizontal datum, or the geographical reference system is for it. And it tells you that the units are in feet. So it doesn't give you an exact ESPG number, it gives you a description of the ESPG number. So this is why you need things like Qgis, because Qgis, you can figure this out on your own by going to Qgis coordinate reference system and looking for these different features that they've described. So they've described NAD83 georeference system, and they said it's in Washington State Plain North for a projection. So we can type in NAD83 Harn and Washington State Plain. Let's see here, Washington North, right there. So it's a NAD83 high accuracy Washington North in feet, and it's most likely going to be in this 2926 coordinate reference system, EPSG. So you can see how Qgis can be handy trying to get to the bottom of that real quickly. You can also simply drop things into Qgis and see where they show up at, and keep changing the projection until, or the coordinate reference system until it shows up in the right spot. So we have the description of the coordinate reference system, but we also have the ability to download a few things. We can download, the first thing we need to download is the last tile index shapefile, because when we look at the last files, we go to that site, we'll see there's a ton of them, and we don't want them all. We would destroy our computer. So we need to figure out which ones we want, and that's why we need this last tile shape index. So you can download that by clicking on it. It will show up in your download directory under this appropriate file name. And then in Qgis, you can take the shapefile you downloaded, and you can simply drag and drop that shapefile onto Qgis. So let me show you how to do that. Here's my file, and here is the shapefile. I grab the .shp file, I drag it, I drop it, and it shows up. Now, this is where the first lesson in Qgis you're going to get is, one, how to use the layering system. First is you can just drag and drop these things in different layers to move them around. You put it on top, it'll cover everything. So it's just like pieces of paper stacked on top of each other. So I'll take that shapefile, put it on the bottom, and you can double click it to open up the different ways the layer may look. The third item down is called Symbology. So we can take the Symbology and change the color of it and the fill of it. So let's just change the opacity to something like that. Press apply, and you should see it go a little pink and things can be seen through. Select the labels button, and we see it says no labels. Let's select the pull down menu and select single labels, and then it'll give you an option of what you want to label it with. So these are the things you can label it with. You can label it with only one item, the ID, and that's all we're looking for. I press that, and now I see the IDs of all the different areas I'm looking for. Now, we might say to ourselves, well, where are we looking to get data from? This is where you can use the second thing that we talked about earlier, which is your plugins for Qgis. You select Web, Quick Map Services, something like OSM is fine, OpenStreetMap, and then you can see the area you're looking for. So in our case, we're going to download all of this area that I'm highlighting and zooming into. Now I'm going to write down these LiDAR square tiles, 47, 122, F3209, F310. And I'm going to turn off everything I don't need for now so I can see it all better. 122, 2106, all the way down till I get all of these tiles. I'm going to take that information and I'm going to go back to my LiDAR file set, and I'm going to do a search for each of those file sets that I decided to download. And it's going to be a .laz file, and I'm going to download each one that I need one by one. So if I needed 122 F3209, I would just do a search for Q1, Q47, 122, F30, 3109, and there it is. I download that, I download 10, and I would continue on until I got all the LiDAR data that I needed, and I placed it into my appropriate folder for raw data. So that's how you can get the LiDAR. While you're here, one of the things LiDAR can be used for is to make a digital surface model. We'll talk more about digital surface models later, and digital ground model as well. But these terms in this case are called the bare earth, which is the digital ground model, and the top surface, which is called the digital surface model in many places. You want to download both of those, and those are very big files. Those are going to be very handy, and I'll show you why later on. But each of those files you're going to want to download, and we'll use them for either making contours directly in Qgis, or we can use them for helping field work or drawing things manually on our computer. So now you've downloaded the shapefile for the tile index, the actual LiDAR tiles, the digital bare earth ground model, the digital top surface model, and that's all you need for here. Now, if this place doesn't have your data that you need, there are other places you can go to. Even within the website for Puget Sound LiDAR Consortium, they have a link to other websites such as the Department of Natural Resources. We have one in Washington, other places do too. And when you go there, it'll take you to their website, which has ways to download data. It has a little map that you can interact with. And this map, you can select what you want and where you want it. If, for example, I wanted to find the area we're talking about, I could zoom in to Lake Washington area in Seattle. And I can hide all this first of all. I could zoom into there and see what products they have available. I could say this is the area I want. And this says this is all the stuff they have. I don't want the 2003 information. The 2016 information is what I want. I don't care about the 2005 or 2003 there. So I want this digital surface model, digital terrain model, and the point cloud. Those are all terms that they use to describe what we just downloaded on the Puget Sound LiDAR Consortium webpage when we found the data for King County. So if you see here, they had the digital elevation model and the top surface dim model, and then the last files. That's the same thing that we're going to download here. It doesn't give us a shapefile or anything like that. In this case, we don't need the shapefile from this website because there's a graphical interface that shows us the area that we're going to download. But you see, this is a very large file set. It's 5 gigabytes, so prepare your hard drive for hard times ahead. Okay, so now you have the ability to get data from a couple places. I'm going to show you a few more possibilities, at least around Washington. King County has its own, so the county itself has its own GIS portal where you can download property information, hydrography such as lakes, water, topography, so pre-made contours that exist in 10-foot increments, political boundaries and whatnot. Those are all very similar. So if I wanted to download the property information, I could go there and it'll give me different things I could download. Here's an example of where I could download the parcel address with information, all of the parcel areas. Let's just say I wanted to select this. I'd highlight it and give me different possibilities of things I could download. I could download it in a spreadsheet, a KML, or a shapefile. Just stick with shapefile for our purposes. And it'll give you all kinds of different things on there. Addresses, city names, plot sizes. Very handy. Also, there's a national map called the National Map at usgs.gov. There's all kinds of great stuff you can download. The National Map Viewer, if you go to that, you can see all kinds of maps you can make yourselves. But there's also a button within here to data download. So if I wanted to download some stuff from Seattle, zoom into the area I want. Let's just say this is basically the area I want right here. I hit the data download button and it takes me to this page, which I got to do the same thing apparently. I guess I've always had to do this and I just didn't remember. Every time I zoom in, the information on the left hand side becomes a subset, a filtered subset based on the area I'm looking at. So there we are, back to the same basic area that I was at before. This is the area I want to download. The things I can download would be similar things. Elevation products. I could get LiDAR data if they had any. Imagery. So let's take a look at the imagery here. I hit the imagery button and I say find products. Now they're telling me that there are some products there. I have products that are JPEG 2000s from the national map, and it shows the area. The footprint can be displayed over the top, and there's the footprint for one of them. Looks like I have 2 images it'll take for me to get. The first one is 27 megabytes, which I'll download. And the second one is 27 megabytes, which I'll download. So hopefully it'll work. And once it's done downloading, you can use those for your maps as well. Also, last but not least, I want to show you the OpenStreetMap data. If you go to openstreetmap.org, it will take you to a website like this. And whatever map you're starting, always go and zoom into the area. And basically, you can snatch all the free data you want that they have on their website for your map making. You hit the export button, and a window opens up on the left-hand side. And you can say manually, first of all, it shows you the extents of the corners of the map that you have drawn, but you can manually select a different area. By doing that, it gives you this little box, which you can select to kind of reduce the amount of garbage you're exporting. And then simply hit the export button. And this says, hey, this is too big. You can't use that much. So I've got to find a way to reduce that some. So I will bring it up just a little tighter in each direction. See if that works. Okay, that did work. It will give you a file called map.osm, and I've downloaded a lot of these, so my new file name is map15.osm. And you're going to save that in your pile of files. Once you get all your data collected, organize it into your file set that we discussed earlier and in your raw data file, and we're going to use that in future lessons in order to start building our map. Play around with that, play around with bringing the data into Qgis, learning how some of the basic functionality of Qgis works, such as styling your data. You can dock a styling widget on the side, you can double click on each layer and change styling and projection properties. All of this stuff you can kind of mess around with, but I'll do it as we go along as well so you can get the idea. But I really think it's going to be useful for you to figure out how to use Qgis, because there's so many great things that you can do with it before you have to get involved with mapping. One of the things that I think all coaches should learn to do is use it, because you can make really quick maps just using Qgis alone. That training maps you don't have to really think too much about. I think it's kind of useful to have kids always running, or athletes in general, always running on a map of some kind, and it'd be really good at, even if it's in a neighborhood, trail system in a neighborhood, you can make maps really fast using this without getting involved with drawing and anything like that, just simply using open source information. The better you get at Qgis, the easier it becomes. So that's it for this lesson. Let me make sure I covered all my topics here. Yeah, so these are all the things you're trying to download and sniff around and try to find what you can. And we're going to start using it in the next lessons. All right, thank you very much. If you have any questions, contact me at tohomaorienteering@gmail.com.